Hi, this is Albert Nixon, Assistant Professor, Department of Chemistry, St. Joseph's College of Arts and Science, Autonomous, Cuddalore. In this video, we are going to discuss about ionic bonding and covalent bonding and various acid-base concept. Ionic bonding. The ionic bond is in which atoms have ability to transfer or share their valence electron, or otherwise called completely sharing of electron one atom to another atom. Conditions for formation of ionic bonding. Two elements must be opposite charge. So one should be an positive charge, another should be a negative charge. An element must have its less ionization enthalpy. Another element must have high negative electron gain enthalpy. So difference of electronegativity between two elements must be greater than or equal to 1.7. High lattice energy of compound formed. This is a simplest representation of formation of ionic bonding. Here we take an example of sodium chloride. Sodium is an alkali metal, chloride is an B block element. The atomic number of sodium is 11. So the electronic configuration of sodium is 1s2, 2s2, 2p6 and 3s1. Chlorine is atomic number 17. So 1s2, 2s2, 2p6, 3s2 and 3p5. Here sodium is ready to ionize one electron or ready to donate one electron. Chlorine is ready to receive that one electron. So the resulting is formation of ionic bonding. Some general properties of ionic bonds. Ionic bonds have the ability to remain in a solid state when they are at room temperature. Their structure is crystalline or transparent. They have high melting and boiling points. They are bonds resulting from the interactions between the metal of group 1 and 2 and non-metal of group 6 and 7. They are quite strong and depend entirely on ions. They are soluble in water and some other aqueous solutions. They are excellent conductor of electricity in aqueous solution. When they are in solid state, they are not able to conduct any type of electricity. Lattice energy. Lattice energy is a type of potential energy that may be defined in two ways. In one definition, the lattice energy is the energy required to break apart an ionic solid and converts its component atoms into gaseous ions. These definitions causes the value for the lattice energy to always be positive. The reaction is endothermic reactions. Lattice energy is used to explain the stability of ionic solids. A lot of energy is released as an oppositely charged ions interact. In its ionic solids have such high melting and boiling points. So Born-Haber cycles. These cycles devised by Born and Haber in the year 1990 that relates the lattice energy of a crystal to other thermochemical data. Here we take sodium chloride. Initially sodium is a solid and chlorine is gaseous state. So it will undergo enthalpy of sublimations. We know what is sublimations. If you heat the solid substance, it will directly into the third part into the gaseous. So the first step, sodium solid converted into sodium gas. Then second step is ionization energy. So the sodium into sodium plus. The third stage is enthalpy of dissociations. The chlorine is dissociated to get sodium. Then fourth stage is electron affinity. So chlorine into chlorine ion. Then finally lattice energy to give sodium chloride crystal. So according to Hess's law, the formation of Born-Haber cycle is Del HF is nothing but enthalpy of formation. Del HS is nothing but enthalpy of sublimations. I is nothing but ionization energy. Del HT is enthalpy of dissociation, and E is electron affinity. U is lattice energy. It is another way of representation of Born-Haber cycle. Covalent bonding. So covalent bonding is nothing but mutual sharing of electron. So both the atom sharing and one electron. Conditions for formation of covalent bond. Combining the atom have to be start by 1, 2 and 3 electrons in the valence shell in the comparison to stable noble gas configurations. The electronegativity between two atoms should be 0 or very small. An approach of atom towards one another should be accompanied by the decreasing of energy. Characteristics of covalent compounds. Covalent compounds usually have low melting points. An exception to this include molecules of silica and diamonds that have high melting point. These compounds have low melting points. This can be attributed to their weak forces of attraction between the various bonded atoms, like van der Waals forces. These compounds are usually gaseous and liquids with low boiling and melting points. The solid covalent compounds have soft structure like graphites. This is because of the presence of cloud of electrons in between each layer of carbon atoms. These compounds are non-conductor of electrical charge. They are bad conductor of heat also. Their molecule lack of free electron and that obstruct the flow of heat energy. So covalent compounds do not possess polar characteristics. As a general property, they are insoluble in water. Polarizing power and polarizability. Polarizing power, it is the extent to which a cation can polarize an anion. It is proportional to the charge density. Charge density is a ratio of charge to volume. Polarizing power is directly proportional to the charge density. More the charge density, greater is the power of polarizing. The next one is polarizability. It is the extent to which an ion can be polarized. It can also called as the case of which spherically symmetric electron cloud of an unsymmetrical electron cloud. Fajon's rule. Fajon's put forward 4 rule which summarize the factors favoring polarizing and hence covalency. Postulates of Fajon's rule. The first rule is a small positive ion favoring covalency, or small size of the cation leads to the covalency. So if you take the alkali metal lithium plus and sodium plus and potassium plus and cesium plus, lithium plus is more covalent because of the first rule is the small positive ion favoring covalency. The second rule is a large negative ion favoring covalency. Large ions are highly polarizable, that is easily distorted by the positive ion. So if you take halogens, fluorine, chlorine, bromine, iodine, so I minus is more covalent because the second rule states that the large negative ion favors the covalency. The third rule is the large charge on either ion, both ion favoring covalency. So high charge is favoring covalency. If you take FeCl3 and FeCl2, FeCl3 is more covalent. And on the other hand, we take calcium chloride and sodium chloride. Calcium chloride is covalent. Then fourth rule is polarization and hence covalency is favored if the positive ion does not have a noble gas configurations. These are the four important rule of Fajan's rule. Next, we are going to discuss about various acid-base concept. First concept is Arrhenius concept. In the year of 1884, Arrhenius find out acid and bases. So according to his concept, an acid is any hydrogen containing compound which give H plus ion in aqueous solution, and a base which gives OH minus ion in aqueous solutions. So simply acid gives proton on dissociation of water, base gives hydroxide ion and dissociation of water. Next theory is Bronsted-Lowry theory. In 1923, Bronsted and Lowry in the year of 1923 independently proposed a more general definitions of acid and bases. According to them, an acid is defined as any hydrogen containing material that can release a proton to any other substance, whereas base is any substance that can accept a proton from any other substance. So simply acid is proton donor, base is proton acceptor. If you take HCl plus H2O to give hydronium ion and Cl minus, so here HCl is an acid, H2O is an base. The next concept is Lux flood concept. This concept was proposed by Lux and Flood. Lux in the year of 1939, Flood in the year of 1947. According to Lux flood concept, oxide ion acceptor is acid, oxide ion donor is base. The next concept is Lewis concept. G.N. Lewis, in order to cover all type of neutralization reactions, gave an idea. According to Lewis concept, acid is electron pair acceptor, base is electron pair donor. Take a simple example, ammonia and boron trifluoride. So here ammonia is having a pair of lone pair of electron. It ready to donate pair of electron. So ammonia is base, that BF3 is ready to accept the electron. So it is an acid. Finally, Usanovich concept in the year of 1938. So according to Usanovich concept, it is a chemical species that react with the base, thereby giving up cations or accepting anions or electrons. Base is a chemical species that react an acid, thereby giving up anions or electrons combined with the cations. Here I explain a simple example. Fe2 plus is base, Fe3 plus is acid. Thank you.